All right, class, this is page 529, example 2. So hopefully you just watched the video on how to get the critical value. This is how to find the test statistic. Here is the information given to us in the problem. Based on our survey, we had 61 who did their taxes by accountant, 42 by hand, 112 computer software, 29 friend or family, and then 56 tax prep service. According to the statistics, we should have 24% use the accountant, 20% by hand, 35% computer software, 6% family or friend, 15% tax service. So this is what we should get, this is what we got. So we're going to use L2 and L3. L2 is going to be our observed, and that's the data we were given. L3 is going to be the expected. So to find L3, after you've entered this all in, okay, you just go to the top here, and we want to take L1 times the total that took our survey. So they usually are going to give this number. If not, you just add these numbers up. But in this case, it gives it to us. It tells us it's 300. So we're going to take L1 times 300. Okay, so here's what we were expected to get. This is what we got. This is what we were expecting. And now we're going to try and figure out if these two columns are different. To do this, we use what's called the goodness of fit test. So go to test, go to test, stat tests, okay, and it's one of the bottom ones here. It's D. Chi-squared goodness of fit. We're just trying to see if they're the same or they're different. Okay, the observed goes in this one here. So our observed was L2. That's where we put our observed data. The expected we put into L3. Okay, that was the expected can have decimals. The observed can't. Okay, degrees of freedom. We have five different things, so our degrees of freedom is actually 4. We have an accountant by hand, computer software, family friend, tax prep service, so we're going to subtract 1 from that, and so there we go. Now we hit calculate, and we end up with a chi-squared value of 16.96. 16.96. Well, that puts us way over here. We're in the rejection region, so we're going to reject HO, and I actually haven't even told you guys what HO and HA are. Let's look back at the problem. It says a retail trade associate claims that the tax prep methods of adults are distributed as shown. So the tax prep is saying that we should get these. Go back to that list. We should get this. We're saying that, so the tax prep, HO, would be that they're equal, okay? That we should get 24%, and you would just list it out. We should get 24% by the accountant, 20% by hand, and so on. You would just list out all those percentages. HA is, they're different. They're not the same, okay? So HO is saying that we're going to get those percentages. HA is saying we're not going to get those percentages. Okay, so we're in the rejection region. So again, we're going to reject HO. So we don't think this is true. Okay, so basically we just rejected that claim. So then you can read what it says on the bottom. There is enough evidence at the 1% level of significance to reject the claim. The distribution of tax preparation methods and the association's expected distribution are the same. So we're rejecting that. We don't think they're the same. Okay, so that's how to find the test statistic, and then you can compare it to your critical value. If it's in the rejection region, we're going to reject HO, and then you're going to have to determine where the claim is. In this case, the claim was with HO. In some of the online problems, you're going to find that the claim is with HA.